So today, well, last time we did triangles, which is three-sided, and then we did quadrilaterals, which are four-sided. So now we're going to do the most logical step, one-sided shapes, which happens to be circles. Now, we don't usually call it a side. We usually call the part of the circle on the outside the edge. So that's the edge of the circle, okay? And I'm going to refer to it as the edge of the circle instead of the side. All right. So we're going to go over a couple of definitions. This is going to be normal notes, so normal style notes, mainly due to the nature of this. You kind of want to draw a lot of these things yourself. So we're going to do normal notes for this section, at least for the next couple of sections. So make sure you pull out a notebook. And we're going to start with circles, 10.1, properties of tangents. Okay. So let's talk about properties of tangents. Now, before we talk about property of tangents, and that word tangent should feel familiar, let's talk about a couple of parts of the circle itself that we kind of need to know. So the first word we're going to talk about the center. Hopefully everyone could understand the center is just the middle of the circle. So the center is the middle of the circle. Most importantly about the center, it's the same distance from every part of the edge. So it's the equal distance from every part of the edge. But all you need to know is the middle. From here, the center to edge of the circle, anyone offhand knows that name? Starts with an R.
It's a radius.
Thank you, man. It's got to be a radius. If I could spell it. So a radius, that's the distance from the center to the edge of a circle. So the radius is from the center to the edge of the circle. I think, Walner, you said it last. So anyone else, did anyone know the name for this type of line in green? Going from edge to edge, passing by the center. Anyone know the name for that one, other than Walner? Give you a hint, starts with a D.
Diameter.
Nice, good job. That's the diameter. So the diameter edge to edge of the circle. Very important, passes through middle or center, I should say. We have an actual name. Edge to edge. So from one edge to the other, passes through center. It's supposed to be a straight line. Mine's a little wobbly, but these are all straight lines I'm talking about right now. And there's just one more type of line that could happen inside the circle. I would not be surprised if no one knew it. And if you don't know it, that's okay. You know, draw it purposely a little different like this. So this is a line inside the circle that goes edge to edge, but doesn't pass through the center. It does not pass through the center. So while diameter does pass through the center, this does not. And this one right here is called a chord. Line inside circle. Particularly does not pass center. If it did pass center, then it would be a diameter. And then it's kind of like our quadrilaterals. Technically, a diameter is a chord, but not every chord is a diameter. Okay? But is a line in the circle does not pass through the center. Any questions on this first circle? That's the blue line over here. All right. Draw another circle for me. We're going to do another circle. And we're going to focus on today's lesson. That's just general stuff of the circle. Those are important, but they're just generic stuff. I'm going to circle. Come here. There we go. Of course, I cheat because I have a nice machine. If you can make a perfect circle, that's very nice, but not necessary. I'll cheat too by using lines instead. I'll use red. So draw another circle. We're going to have two more type of lines. Now, these lines interact with the outside of the circle. Our first one we're going to talk about hits the circle exactly once on the edge. Come here. There we go. So let's say it hit the circle exactly at one point. We could kind of say like right there. Something like that. Yeah, that's pretty close. Either way. So it scrapes the circle, only hits it once, just scraping right by. That one is a familiar term that we used a lot in trigonometry section, but this one is called the tangent. Line that hits the edge of the circle exactly once. Very important. The tangent exactly hits it once, just scrapes it like this. Now, any point of the circle could only have one tangent. The reason is, let's say if this line was a little bit leaned to the right. If it leaned a little bit to the right, it would hit the circle twice and then stop being a tangent. If it leaned a little bit to the left, it wouldn't hit the circle at R. So it's a very precise line, guys. It's a very precise line. So it hits the circle exactly once, like that. While here, what we're going to do next is not so precise. This is a line that hits the circle twice. This is also a trigonometry thing. This is called secant. S-E-C-A-K-N-T. The secant. Now, we didn't do this in our trigonometry, but this is the opposite or the reciprocal of cosine. Very interesting. We won't talk about the relationship between the triangle and the circle for a long time, if ever, but these are related to the tangent line of a triangle and the secant line of a triangle. So secant line that hits the edge twice continues outside the circle. So a chord does hit the circle twice at the edges, but secant is continuing on, so it goes outside the circle, okay? So these are lines that deal with outside the circle. The lines previous deals with circle lines inside the circle. Any questions on that? All right. So now we're going on the next set. Draw the circles kind of relative to mine. So draw a circle like here and one like to the right of it. Kind of like the same level. As best as you can. So two circles kind of next to each other like that. Try to be the same size-ish. And then this section, I'll give you a title for this section, will be common tangents. Okay. So this is common tangents. So a common tangent, I guess I should put down the definition. A common tangent, you could either put a line right next to the title or just rewrite this. What that is the same tangent line between two circles. So it's a tangent line that they share between two circles. So how many tangent lines can two circles that are outside of each other possibly have? Well, you could have one line that goes through the top, kind of like this. So I'll put like one like here. Try my best to make it as nice as possible. Again, if your line's a little crooked, your circles are not perfect, it doesn't really matter. So a line on top like that. Remember, it has to be very particular though. Like the actual line is very particular because a little down dip, you're gonna have it's gonna hit the circle twice. A little too high, doesn't hit the circle at all. So it has to be pretty close. There has to be a very particular line. We can have a line like that. We can have another line that's kind of on the bottom like this. Now, even though you can see my circles aren't the same size, and if you hand drew it, your circles aren't going to be the same size, there's still exactly one tangent line on the outside here. You just have to readjust it a bit. The problem is this is not adjusted the way I wanted to. So I'll just draw it. Something like that. So it doesn't have to be parallel, these two tangent lines. This one's a little bit more hooked up. So that's two so far. You could technically have a tangent line like this, kind of going across this way. And you could have a tangent line like this. So when you have two circles not touching each other, This one will have 1, 2, 3, 4 common tangents. These circles will have 4 common tangents. There's 4 lines that hit the circle exactly once on the edge. If it hits more than once, it stops being a tangent and starts being a secant, which is not useful to us. We want it as a tangent. So when 2 circles do not intersect, it's 4. I want everyone, after you write that down, draw another pair of circles, but this time have them touching each other just a little bit, like right there. And particularly exactly 1 point, let's say. Have 2 circles like that. Everyone try to draw that. After you draw that, you guys try to draw how many possible common tangents there are between these 2 circles. Then you could type it privately to me, and I'd tell you if you got them all right or if you're missing some. So tell me the number of common tangents this could have. Waldner, you don't got it right. There could be one more. Where could you put it? Try to think about it. So everyone try. Yeah, exactly, Waldner. Right down the middle. Sure. I want you to draw these 2 circles. And then, so like one's bigger, one's smaller, but most importantly, they're touching, Shul. And then the red lines I drew previously, those are very specific lines that hit the circle once. How many of those type of lines can you draw when the circles have this setup? Angela, excellent answer, correct. Ortel, you're missing one. There's another one you could fit in, but you're correct. There's one here and here. So figure out where that third one could be. Yeah, exactly, Ortel. Good job. Shoal, great job. Good. How many people I actually have here? 10 people. I'm missing half my class. Yeah, about half my class. That's not good. Good thing I'm recording, yes. Kira, you got the top and you got the bottom. There's one more you can figure out. Lael, good. Kira, where would that third one be? Julia, that's okay. I'll post the recording later for you. All right. So if you try this exercise, you would have had got one on top, something like here, one on bottom, something like here. Now, there's a third one that you could possibly have, which is right here, exactly through the middle. Because if they're touching, the circles are touching at exactly 1 point. That means there's that 1 point they both share, like right in the middle, that you could hit exactly with a skinny line. Because remember, the line is really skinny technically. Like it doesn't really take any width. So it passes through that exact 1 point. So when circles are touching or adjacent to each other, there's 3 common tangents. Okay. Let's try another set. This time, draw 2 circles, but have 1 circle be inside the other circle. Just like this. And I'm going to challenge you to the same thing. The circle does not have to be in the middle, but it doesn't really matter where it is inside the bigger circle. It could be anywhere in the circle. Looks like a cell with its nucleus, right? From biology. Either way, this one, how many common tangents can you draw? Try it out. Walner. That's a good idea. Maybe that's true. Shaul, that's too many. That's definitely too many. Nothing because of touching. Let's see. So just look at it. Maybe Shaul. So if you looked at it, you know something's weird. And Shaul, you got it. Good job. Now, somebody said two, top and bottom, but the issue is if I draw a line that's tangent to the bigger circle, if I try to make the tangent, let me move this to the side so I can move my chat box. My chat box is in the way. In this one, here, I cannot get it inside because what happens? The line stops being a tangent to the bigger one and starts becoming a secant. So I can't put it inside like that, which means there's no way I could hit the circle that causes it to like go inside without going inside. So because a tangent line can't go inside a circle, that means when you have a circle inside another circle, there are, let me delete this so there's no confusion. Can you delete, buddy? There you go. That means that's 0 common tangents. So circle in a circle, 0 common tangents. Let's try again. More common tangents. Have a circle like this, and I have a circle like this, kind of like a Venn diagram. Same process. How many common tangents there are? Sure. Fastest on the trigger, and you're correct. Right on target. Good job, Shul. How many common tangents could be in these two circles? Kind of looks like a Venn diagram. Angela, I would agree. Walner or Tell, I would agree. Give about 10 more seconds. Just look at it, admire it, think about it, let it marinate in your head a little bit. Leo, good job. Okay. In this situation, we only could have one on top that hits both and one on bottom that hits both. So in this case, there's only 2. We can't fit the one in the middle because if we try to draw a line in the middle, it would hit the circle twice, which is not okay. So in this case, there's only 2. So if you have a Venn diagram kind of setup, you have 2 common tangents. So that would be 2 common tangents. And I'm going to give you the answer to the last one because probably you guys should figure it out by what's the number that's left over. But here you're going to have a circle that's inside the other circle, but they share an edge point, something like here. Yes, both lines have to touch the circle in order to be a common tangent. Ashul could see the pattern right away. If this hits the edge at one exact point, and Angela could see the pattern right away. So you have a circle inside a circle that's on the edges, on the edge of each other, or sharing an edge, you could say. Let me draw, please. There we go. You're to have exactly one tangent line, kind of like a, what is this design? Kind of looks like a full moon, actually, kind of like that, or like a crescent moon. Something like that. But a circle in a circle that's at the edge is only going to have one common tangent. There's only one way to draw the line that doesn't go inside, but still hits both circles. So there should be one common tangent. My smartboard's being a little laggy, so I apologize for that. One common, okay, what am I writing? One whatever. You know it's 1. Okay. And as it seems like my laptop seems to be crashing on me. Let's see. Is there anything else? So let's see. I want to accomplish today. Common tangents. I can save the equation stuff for tomorrow. I'll save the equation stuff for the next time. So in this case, yeah, okay. So this is going to be the end of our lesson. Anyone who's here, type here for your attendance so I can save your chat.